Worksheet. This is about this is new topic, verbal description. Well, we are still in the set theory, but now we are going to understand how verbal statements can translate to sets. 1 second. So we understood A union B, the formal definition of A union B as a set of all x such that x belongs to A and x belongs to B. So the word is and here. It should be in both. The x should be in both to belong to the intersection. When it is A union B, it's x belongs to all the x's such that x belongs to A or x belongs to B. So to be in the union, it has to be in A or in B. So those are the correct words. So when you're translating verbal descriptions to set notation, you have to pay attention to those words. Also, to do this, De Morgan's laws can be used to make the problems easier. Right. So, all right, people came in late. I had to admit them. Anyway, so De Morgan's law will be useful. So remember, I explained that it will come in handy if you remember it. So let me write that on the board. If you have A union B complement, that will be equal to A complement intersection B complement. So if you see A complement intersection B complement, and if you interpret that as A union B complement, the problem would become easier. This is one of the two De Morgan's laws. The second one is if you have intersection first and then complement, then you get complements union. The operation is opposite for the other side. So these two are the De Morgan's laws. Don't be surprised if one of the test questions asks you to write the De Morgan's laws, because it's so important that it can be a test question. Anyway, we're going to do one example with several parts to understand exactly how to translate the sets to verbal description or going backward, verbal description to sets. So here's an example. U represents set of all students at John Jay College. S represents the senior students. All the senior students fall into the set S. C is going to be criminal justice majors at John Jay. With that, what is the description of S intersection C? S intersection C would be all the students who are in S as well as in C, both. So that would be, when you want to verbally describe it, you would say seniors at John Jay College who major in criminal justice, or seniors who major in criminal justice at John Jay. You know, you can use your own wording, but it has to come out right as a description of that set. So the students must be seniors as well as criminal justice. So how do you say that? Seniors at John Jay College who major in criminal justice. Now, when it is a union C, you have to be careful. This is now union, so the student can be either senior or criminal justice major. So I would say this way: John Jay students who are either seniors or major in criminal justice. See, the word is or. If you put the word and there, that's completely wrong. C prime means everybody outside of C. C is students who are majoring in criminal justice. So C prime would be students who are not criminal justice majors. John Jay students who are not criminal justice majors. Okay, now S intersection C prime, S would be seniors, C prime would be non-criminal justice majors. So seniors at John Jay who do not major in criminal justice is the verbal description. If it asks you for S union C complement, it's going to be harder to translate S union C complement than S complement intersection C complement. So I'm applying the De Morgan's law to get S complement intersection C complement, and now I can say it easily. S complement would be non-senior students. C complement would be non-criminal justice majors. So non-senior students at John Jay who do not major in criminal justice. That's what the description for that is. Okay, so with that one example, you should be able to answer these questions. So let me describe the sets. Universal set is set of all the employees at IBM company. P represents computer programmers at IBM company. S represents employees who are smokers. F represents female employees of IBM. With these notations, how to describe F prime in words?
Is it not female employees at IBM?
Who are not female?
Yeah, there's a better word for it.
Male employees.
Male employees, right. Male employees of IBM. That's right. Okay, S prime.
Wait, I'm sorry. So for the letter A, it would just be male employees?
Yeah, for part
IBM.
A, the answer is male employees of IBM.
Oh.
Okay. S represents smokers at IBM. So S prime will be?
Non-smokers?
Non-smokers, non-smoking employees of IBM. Right. I'm going to write down for those who need it. Okay, P represents programmers, S represents smokers. So how would you describe P intersection S?
Computer programmers who do not smoke.
These are smokers.
Programmers that do smoke.
Who do smoke, right? Computer programmers who do smoke, right? I don't have complement here. I have S, P intersection S. So programmers who smoke or smoking programmers, whatever way you want to say it. But these are employees who smoke and they are programmers. So programming employees who are smokers. You can say it in different ways, but if it comes out right, then you're good. When it comes to union, you have to be careful with the words. This is union. So can anybody describe this?
Computer programmers and employees that smoke?
No.
Is it or? It's or, right?
Or, and then what? No, the statement was not quite right. They are all employees of IBM. So you had to use the words for the correct words for the P and the S. P represents programmers, S represents smokers. So if you combine them, how do you describe?
Computer programmers or IBM employees who smoke?
That's an awkward way to put it. How about
Maybe
IBM employees who are either smokers or computer programmers.
right? It's to employees who are programmers or smokers, right? As simple as that. So the word is or when it comes to union. Very common mistake is to use the word and that will come out wrong. Now this one is intersection. P intersection S prime. Okay. P is programmers, S is smokers. So what is P intersection S prime?
computer programmers who do not smoke at IBM.
Right, very good. Computer programmers who do not smoke. Okay. Next one is P intersection S intersection F. P is programmers, S is smokers, F is female.
Programmers who do
Female.
smoke and are female.
It's correct, but that's awkward English sentence. There must be a
Female computer programmers who smoke.
right, exactly. Female programmers who smoke. Very good. P union S intersection F prime. F prime is male, right?
Male IBM employees who are either computer programmers or smoke.
Right. Male employees who are either programmers or smokers. For the union part, you have to use the word or. Okay, S union F prime. This will be easier if you apply the De Morgan's law. What does it become if you use De Morgan's law? The prime means complement. So apply the De Morgan's law, what do we get?
S complement,
Uh-huh.
yeah,
Interse-
U, yeah, not
Inter-
intersecting, it's the,
Union.
yeah, intersection is the upside down U, right?
S union F prime.
F prime, right. So S complement of S intersection complement of F. Okay, can you now describe it?
I have a question. So when prime is being like multiplier added to the element, we switch the union into intersection?
That's the De Morgan's law. See on the board, if you have
Yes.
union of two sets complemented, then individual complements will be intersected. Okay, that's the De Morgan's law. We verified it in the last class, and we are trying to apply it here. So S union F prime is same as S prime U intersection F prime. So now it's easier to describe. If you use this original form, it's harder to describe. So can you describe this?
Employees who are not smokers or females.
Non-smoking female employees, right? Okay, so employees who are not smokers, and also they are male. I'm sorry, male, not female. So male employees who are smokers or male smoking employees, things like that. Maurice is having trouble with the system.
So the answer for that for age would be male non-smoking employees or
For age, yeah. Male non-smoking employees, right? Okay. Write it down if you need to. I'll write it whenever I can. Male non-smoking. Okay. So if you apply the De Morgan's law, it usually comes out easier. This is also S union F prime. So that's going to be same as if I apply the De Morgan's law, it becomes S prime intersection F prime. And then another intersection, P. Right? So if it is intersection, it's usually easier to describe. So anybody?
male non-smoking employees that are computer programmers?
Right, exactly. Male non-smoking programmers or non-smoking male programmers. Those are different ways to say it. So these words, the description can be, different, more than one. Each one of you may have a different, slightly different way of describing it. So therefore, questions of this kind will be multiple choice on WebAssign because they want to, they cannot accommodate all your variations in answers. So that's all we need on that verbal description. Let's move on to count of a set. Count of a set means number of elements in that set, the count. So the notation is n parentheses a. Whenever you see this notation, you need to know that it is count of the set A. That's what it means. It represents number of elements in A. It's a very, very simple concept. So if A has these elements and B has these elements, count of A means how many elements are there? How many are there?
5.
5, right. Count of B is
4.
4. Count of A intersection B. For that, you had to find the A intersection B. What are the elements in the intersection?
9.
9, 7.
Would be 2.
So 2, 9 and 7. So count is 2. Okay, now going to the Venn diagram. The count of elements in each section is given. So the 9 is the number of elements in the part of A that's outside of B. 4 is the number of elements common to A and B. 11 is the number of elements in the part of B that is outside of A. 10 is outside of both circles. They write the 10 anywhere outside. That means 10 is the number of elements outside both circles. Okay, can somebody tell me count of A?
1.
13.
I heard it one more time.
13.
13 is correct. Everybody see that count of A is 13, not 9. 9 plus 4. Count of A prime.
10.
21.
21 is right. You had to count the 11 and the 10. They're all outside of A. Count of A union B.
24.
24 is right. If anybody's not following, please interrupt and ask the question. It's
Yeah, I want to know how come we're adding them, but we didn't do that in exercise 2.
in the part B.
Yeah, in exercise 2 we didn't add them. So I want to know.
Previous one. Exercise 2, count of A is the count of number of elements in A. There are 5 elements, right?
Mm-hmm.
In B, there are 4 elements, right?
Yeah.
Intersection has A intersection B has 7 and 9, and so 2 elements in the intersection.
I understand that part, but I thought we was going to be doing the same thing in exercise 3, but instead we're adding.
Exercise 3 gives you, it doesn't give you how many elements are in A. The 9 here is the elements that are in this section. I think you have trouble seeing that. Let me go to the board. Contreras. 1 second. Okay, so I think you are, hold on. Let me draw the circles here. The 9 elements shown in the figure is 9 for this section only, okay? And 4 for the common section for between A and B. The elements that are common to A and B, that's 4. The 11 is only this section, okay? So the question asks you how many elements are in A. Can you see that? That's 9 plus 4.
Yeah, I see.
Okay, there are 9 elements in this section, 4 elements here. 9 plus 4 is the total number of elements in A. Now this problem is different from problem A. Problem A gives you exactly what elements are in A. So you counted them. This problem gives you number of elements in each section on this Venn diagram. So you have to add and subtract to get the answers. Okay, so A prime means complement of A. So everything outside of A will be counted. Outside of A, there are 11 elements, these 11 elements, and these 10 elements. Outside both circles, there are 10. So add them up, 21. A union B will be 9 plus 4 plus 11, and that's 24. Now, can somebody tell me the number of elements in A intersection B prime?
13.
23.
9.
9 is correct. I heard two other answers that were wrong. 9 is correct because A intersection B prime, we went over in the last class. You had to figure out what that is. A intersection B prime means common area of complement of B and A. In other words, what part of A is common to complement of B? That's this. This is a part that A shares with complement of B. And there are 9 elements there. Count of the universal set. Okay, how do we figure that?
It's 34.
34. Add up all of them. That has to be the universal set. 34. This is 9. Okay, moving on to exercise 4. Exercise 4 gives you the number of elements in the universal set as 22. And then 5, 4, and 6 are the number of elements in each section. So we need to figure out how many elements are outside the 2 circles. Can somebody tell me how many are there?
7.
Right. 15 elements are in the 2 circles. So subtract that from 22, you get 7. So there are 7 outside. Okay, now can somebody tell me count of A?
5.
9, right? Not 5. The 5 is only in the left side of A, the part of the A that's outside of B. Okay, so 5 plus 4, 9 is the total number of elements in A. Okay, part B, anybody?
4.
4. Count of the union?
16.
15. Count of the complement of union, A union B prime? Anybody? Nobody can
7.
see it? Say again?
7.
7. The number of elements outside the 2 circles. A union B means the 2 circles together. And outside of that, there are 7 elements. A intersection B prime.
5.
Right, 5. Very good. A prime union B.
6.
13.
13. A prime union B. Let's see. Prime union B.
10.
Not 13. I think someone said 6. No, that's not it. A
10.
prime.
10.
What was that?
10.
No,
Is it 17?
17 is right. Okay. I'm glad one student got it right, but I'm going to explain. I know it's a little bit tricky. I'm going to explain on the board. A prime union B. All right, let's pick up the pencil. Okay, so I'm drawing the Venn diagram. Okay, this is A, B. A is the entire circle, B is the second circle. Let's shade the A prime. A prime is everything outside of A. that would include part of the B. That's A prime. So part of B is included there. Now, so what I marked here is A prime, the complement of A. If I combine the B, if I combine the B to it, part of the B is already there. So only part that was missing will be added. That's this part right here, the center part. That'll be added in when you add the B. So that's what A prime union B is, all of the region that is shaded. And the count of that is 4 plus 6 plus 7, right? 4 plus 6 plus 7, 17. There are 4 here, 6 here, and 7 outside. So that's why it's 17. Going on to next, so that's 17. Going on to part D. A complement intersection B complement. Now that
7
7 is right. Okay, very
equal
good.
to D.
Equal to
D. In exercise 4, the same thing.
exercise D. That's what we're doing. It's equal to 7 is right. And let me explain for those who don't see it. If you have A complement intersection B complement, that's what we have here. And that's hard to figure out what region it is. But if you apply the De Morgan's law, A union B complement. A union B complement is obviously 7, right? A union B would be 2 circles together. Complement of that is outside of the 2 circles, which is 7. So always if you apply De Morgan's law, the problem becomes easier, remember. So whenever you see that it applies, you should apply it. So here it's A complement union B complement. So what should that be?
18.
18. No. Oh, I'm sorry, you're right. 11 is 8. So yeah, it is 18. I added them wrong. 18 is right. Everybody see it, or do you need explanation?
Can you explain it?
Okay. Again, if you just look at A complement union B complement, it's hard to figure out what that is. But if you apply De Morgan's law, this is the same as A intersection B complement. I'm applying the De Morgan's law backwards. So A intersection B complement means everything outside of A intersection B. So A intersection B is 4. So everything outside of that is 6 plus 5 plus 7, right? So that's why it's 18. Everybody got it, or anybody needs explanation again? I applied De Morgan's law, so it became A intersection B complement. So that means everything outside of the intersection. Intersection has 4 elements, so everything outside of that would be 6 and 5 and 7. Okay, so moving on. In the last example, we had 5 elements in left side of A, 4 common to A and B, 6 in B. Okay, let's take that same example. We're going to use it to derive another formula that will be useful. What is the count of A here? We figured out already in the exercise 4 that count of A is
9.
9, right? And count of B is what's the count of B? Anyone?
10.
10. So count of A plus count of B is 19, but the count of union, A union B, is not 19. Count of A union B is the 6 plus 4 plus 5, right? That's 15. So count of A union B is not equal to count of A plus count of B. If I just add count of A and count of B, I'm getting 19. So why am I getting 19 when I add count of A and B? Because the count of A includes the 4, the one in the middle. And count of B also includes the 4. So when I add count of A and count of B, the 4 is getting added twice. And that's why we got 19 when you add count of A and count of B. So count of A union B is 15. So how do we get the count of A union B from count of A and count of B? Here's how we can do that. Count of A is 9 plus count of B is 10. If you add them up, that's 19. And this is not same as count of A union B because the 4 is added twice. So if I subtract that 4 once, then I should get that right. So we will just subtract count of the intersection from that, then the count will be right. Now the A has 9, B has 10, and subtracting 4 gives you 15. 10 plus 9 minus 4 is 15. So because the intersection is added twice, you subtract it once. So we have a formula. Count of A union B is equal to count of A plus count of B minus the intersection. This is called the union rule or counting formula for sets. Counting formula for sets or union rule. 2 names are there. So you need to remember those names. The books, different books may use different names. Union rule or counting formula. Anyway, we can apply that to do problems like the following, example 2. We can always use the Venn diagram. If you use Venn diagram, then this formula would not be necessary. If you want to do it directly, algebraically, then this formula is useful. So here's example 2. It says count of A is 20, count of B is 15, count of A intersection B is 12, find count of A union B. So it's this formula directly applicable. Count of A union B equal to count of A, which is in this case 20, plus count of B is 15, minus intersection 12. So 5 plus 20, 35, so 23. So that's your answer for the union. So this is example 2. Going to example 3. It gives you count of A, count of intersection, count of union, and asks you to find count of B. So we can write the formula first. A union B equal to count of A plus count of B minus count of A intersection B. In this case, they're not asking for the union. The count of union is given as 38. So put that number in for 38. Count of A is given as 23. Count of B is unknown. Put an X in place of that. A intersection B is given as 10. So now you have an equation with one unknown quantity. So you solve it for X. 38 equal to 23 minus 10 is 13 plus X. Subtract 13 from both sides, then X equal to 25. So you conclude that count of B equal to 25. That's what we called X. So basically, if they give you any 3 of the numbers in this equation, in this formula, any 3 of the numbers in this formula, you can find the 4th one, no matter what it is. Okay, so let's see. But remember, this formula doesn't have any complement. It is direct, straightforward union of 2 sets. Only for union of 2 sets, you can apply this. If there are complements and things in the problem, you can only use Venn diagram. Venn diagram applies to any of these problems, but the formula applies only for specific type of problems where there are no complements or anything like that. Exercise 5 says intersection of A and B has 6, union has 30. A bar intersection B has 9. Find count of A. So this one gives you information that cannot be used in that formula, in the counting formula or union rule. So we have to go to the Venn diagram to do this. So let me show you how to do that. So you raise the board. Okay, doing exercise 5. Put down the information on the picture. We need 2 circles for A and B. On Venn diagram, you should always mark the numbers for the sections of the circles. So if you don't know the section, don't put that number in. Count of A intersection B is 6, it says. We can put that down on the problem, on the picture. 6 goes right there. And A union B is 30. Now we cannot put that in there anywhere. That's for the 2 circles together. So we just have to remember that. What would be the 9? Where do I put the 9?
In B?
Part of the B that's outside of A, right? The right half of the B. Everybody see that? We learned in the last class how to figure out these things on the Venn diagram. A bar intersection B would be part of the B that's outside of A. And that's what this section is. And that's 9. So it says find count of A. So to do that, we're going to have to do some work. First, the only piece of information I haven't used is the count of the union is 30. No, is it? Yeah, 30. So what can I get from that? What can I calculate from that? Anybody?
30 equals x plus 9 minus 6.
X plus 9 plus 6.
X plus 15 minus 6 equals to 30.
Right. The 30 includes this section, this unknown section. So the students are calling that X. That's fine. Call that X. So X plus 6 plus 9 equal to 30. So in other words, if you subtract 6 plus 9 from 30, you should get the value for this X. X plus 6 plus 9 must be 30. So therefore, 6 plus 9, which is 15, X plus 15 is 30. So X equal to 30 minus 15. So therefore, there are 15 elements here, right here. That's what we have calculated so far. And we don't know the outside, how many elements are outside, but there is not enough information given to us to figure out the outside. So we assume that we don't need that to answer the question. The question is, what is the count of A? Okay, so we don't need the outside to answer the question. So what is the answer to the question?
So the answer would be 15.
No, not 15.
So what would be the answer?
The 15 is this. Understand?
Is it 21? It's 9.
Is it 21?
You have to add the 6. In the Venn diagram, we only show the numbers for each section. So the entire A is 15 plus 6. You need to add these. So the answer to the question is 21. Okay, exercise 6, I want you to do it. Go ahead. Do it on your paper and have the answer ready.
It's 16.
16 is right. Very good. Okay. Um, anybody needs my explanation or everybody got it? Everyone got it? Okay, moving on to exercise 7. Yeah, I want you to do that too.
Actually, how did we find 16? Because when I was doing it, I thought the answer would have been 18.
You got what, 15?
18.
18. Okay. All right, I'm going to do it. I'm doing exercise 6. For those who have completed it, can go on to 7 and have those answers ready. So exercise 6, I have to mark those numbers first. A union B is 20, so I can't mark that. A bar intersection B is 8. A bar intersection B is the part of B that's outside of A, and so that's the part that is 8. 8 is this section of A, section of B. A intersection B bar is 4. A intersection B bar is the left side of A, and that's 4. A union B is 20, so we can't mark that, but using that A union B information, we can find the intersecting part, this unknown part. So basically add 8 plus 4 and subtract from the 20. 20 is the total of all 3 of these sections. 8 plus 4 is 12, so 20 minus 12, 8 is what this is. 8. So we have 8 elements in the intersection, 8 elements on the right side of B. So 8 plus 8, 16 is the total count of B. Okay?
Okay, got it. Thank you.
All right. Anybody has answer for exercise 7?
Yeah, the number of elements in B is 14, and then A union B is 22nd, and A intersect B complement is 8.
8, okay. Very good. I'm going to verify that in a second. Okay, A and B. What is given to us is universal set has 30, so I can put 30 outside the rectangle. Count of A is 12. So that's these two sections together is 12. So I don't want to put the 12 inside anywhere. I write that outside. So that A, next to the label A, if I write 12, that means the entire A has 12 elements. And A intersection B is 4. I can put that in. 4 goes right there. And then A complement intersection B, that's part of the B that's outside of A, which is this section right here, the right section of the B, and that's 10. Okay, so those two are given. Okay, using that information, we need to find the remaining sections. So what we can do first is entire A has 12 elements, and this part of the A has 4 elements. So how many are here? Anybody?
8.
8. Subtract the 4 from 12 to get the left side of A. There are 8 elements now. So now we can compute what is outside the 2 circles. Add the 10 and the 4 and the 8 together. That's 22. Take away 22 from 30. That gives you 8. So there must be 8 elements outside, right? 30 includes everything outside the 2 circles and the inside of 2 circles. So if you subtract the inside of the 2 circles from the 30, that gives you the outside, 8 elements. Okay, let's start answering the question now. Count of B will be 4 and the 10 together, which is 14. So this one was right with that. Part B is count of A union B. That'll be 8 plus 4 plus 10. That's 22. That's correct for part B. Part C says A intersection B complement. A intersection B complement means part of the A that's outside of B, which is this 8. So the 8 is also correct. Very good. That student had the right answers. Any question on that? Very good. Moving on to applications. So everything we have learned so far is to apply to real world problems for calculating questions like the next one. These things apply to real world situations. So let's start with a simple example, and we're going to build up our way to harder examples. So in this example 4, in a state test was taken by 600 students, and 220 students had passed math component, 310 passed English component, 90 passed both. How many students passed? All these questions are there. Now, before you get to the question, you should put those numbers on a Venn diagram. Venn diagram is always the best way. Now, sometimes you can just use the union rule to answer the question, but almost always Venn diagram is necessary. So let's draw the picture. The number of students who have taken the test is 600. So that's our count of the universal set. We are only dealing with the students who have taken the test. So therefore, there are 600 elements in the universal set. And 220 students passed math. So I'm going to represent this circle for the students who passed math. So M represents students who passed math. You don't need to write down these definitions, but you can mark them directly on the picture. I'm going to call it M, and number of elements is 30. I'm going to put that on top, sorry, not 30, 220. I'm going to put that number right outside the circle, because inside the circles, you have sections, and you should write the sections only, the number of elements in the sections. If you don't follow that rule, you can end up messing up everything. So the number of students who passed English, I'll call it E, and there are 310, so I'll put that 310 here. And then 90 passed both. Where do I put that?
In the middle?
Middle.
Middle. The people who passed both will be the intersection. So 90 goes here. All right, that's the information given. So we have to work out the rest of the picture, all the unknown areas that before going to the question. Don't even bother to read the question. Figure out the rest of the sections. Can we figure out the left side of the M? How do I do that?
220 minus 90.
220 minus 90, that's right. 220 includes the 90. So if I subtract the 90 from 220, that'll give me left side of M. So that's 130. Okay, right side of E.
310 minus 90 equals to 220.
Right, 310 minus 90 is 220. If anybody's not following me, please ask the question. So subtract 90 from 310. 310 is the total count of E, so subtract 90 from that. That gives you 220 for this section. Finally, I want to count the outside of the two circles. What do I do?
Wouldn't that be including 600?
Yeah, 600 includes the outside. So what?
You would add the numbers that are in the circle together and subtract it by 600?
Right, very good. 130 plus 90 plus 220 is the sum of the elements in both circles. That's the sum of both circles. If I take it away from 600, that'll give me the count of the outside. Okay, so 220 plus 130 is 350, 440. So this adds up to 440. So 440, 5, 6, 160. 160 is the outside. Okay, so we have all the numbers, and now we can start answering questions. Now, remember, you have to interpret the questions correctly also. How many students passed at least one of the two components? At least one means one or more. Okay, so how many students have passed one or more of the two components? That isn't that same as union? Do you agree with that? All the students in the union passed one or more of the sections, right?
Yes, because they either passed one or the other.
Right, one or the other. So basically, how many passed one or the other, or both. So that would be the count of the union, which is 440, right? So the answer to the first question is 440. Part B says, how many passed only the math component?
130.
130 is correct. As you can see, the 90 students passed both English and math. The 130 students passed only math. C is how many passed only one of the two components?
Wouldn't that be 130 plus 120?
220, yeah.
Oh, 220, yeah.
Yes, that's right. 130 plus 220, that's 350. These 130 students and these 220 students passed only one of the two components, either math or English. How many passed neither of the two components?
$160.
160. Okay. Any more question? Any other question on that? Okay, now I'm going to do exercise.
Did we get 160 by adding the inside and then subtracting?
No, 160 is outside the two circles. And the question is, how many passed neither of the two components? You see that?
I just wanted to know, how did we find the 160?
How did we find the 160?
Yes.
We added all the numbers inside, 130, 90, and 220. Came up 440.
Oh, yes.
Take the 440 off of the 600. That gives you the 160 outside.
Okay, thank you.
Okay, exercise 8 is a little bit tricky, so I'm going to do that. It was meant to be exercise, but should be exam. So erase the board. 100 college students were surveyed after voting in an election involving Democrats and Republicans. 42 were female students, 50 voted Democratic, 25 voted were male students, voted Republican. All right, so with all these numbers, if you try to answer this question without using set theory, impossible. How many female students voted Democratic? That's the question. So the set theory is necessary to be able to answer this question. So I'm going to put all the numbers on the picture. So let's pick up the pencil. All right, so here is, but there are several things going on here. As you can see, there is Democratic and then Republican, and then there's female and male. So 4 things. Are you going to draw 4 circles? No, not really. You have to pay attention to the details here. There are Democrats and Republicans involved, but they are complementary. People can only either vote for Democrat or Republican, not for both. So therefore, they are complementary. So if I draw a circle for the Democrat, everybody outside of that circle will be Republican. Okay, only one circle for Democrat or Republican, either one. So I call this Democrat. That way, everybody outside is Republican. And then there are females and male students. Again, only one circle, either for male or female. The other one is complement. So 42 female, 21 male students voted Republican. All right, anyway, you can call it either. The second circle is either female or male. So I'll call it female. Then everybody outside that circle would be male. Okay, let's now mark those numbers. 42 were female students. That means the second circle has 42 elements. Write that outside the second circle. 50 voted Democratic. So 50 students fall into this first circle. 50. So again, I write that outside because there are 2 sections. Together, there'll be 50. 25 were male students who voted Republican. Where do I put that 25? Anybody see that?
The outside?
Outside of what?
Outside of Democratic, I think.
But 25 were male students who voted Republican. So they had to be outside the Democrat, right, to be Republican.
Would it just be outside of both circles?
Outside of both circles, exactly. So male students who voted Republican means the students are outside the Democrats and outside the female. They're male and Republican. So they're outside of two circles. So 25 are out here. And total number of students that they are looking at is that given? 100, yeah. So 100 students is the universal set. Okay, so now we need to figure out all these three sections. We don't know any of the sections, right? So it's a little bit tricky. I can figure out the number of elements in the union of two circles by doing what?
100 minus 25.
Right, very good. 100 minus 25 equal to 75 must be the two circles together. There are 25 elements outside the circle, so there must be 75 inside the circles. So we have two circles together, but we don't know each individual section. We know two circles together. So there are two ways to handle it. One is to apply the union rule, count of A union B equal, in this case, that's count of D union F equal to count of D plus count of F minus count of D intersection F. This is one way. There are other ways. If I apply this rule, I know the union has 75 elements and the D has 50, F has 42. So I can figure out the union in the intersection from this. So call the intersection X, then 75 equal to 92 minus X. So X is equal to 92 minus 75. 80, 90, 15, 17. So that's the intersection. The intersection has 17. So once you figure out the intersection, everything else is straightforward. Okay, so I have 17 for the intersection. So 50 minus 17 is the left side of D, and that is 33. Yeah, 33. And 42 minus 17, 25 for the right side of F. And so once you get that, you can answer all the questions. Now, I said this is one way, applying this. We kind of had to apply this because we had the entire D available, entire F available, and the union available, but we didn't know the intersection. So we applied this formula to get the intersection. That's one way. We can find it directly on the Venn diagram without using union rule. It's a little bit tricky. Now, let me see if you can see that. I have 50 here and 42 here. I'm explaining the second way to get the sections. 25 here. So the total count is 100. So the two circles together is 75. So the two circles together is 75. And this much is 50, right? This is 50, but two circles together is 75. So you see that 75 minus 50 should be this, right? The two circles together is equal to 75, right? This entire circle is 50. So this part must be equal to 75 minus 50, 25. Are you following me? Anybody?
Yes.
Okay, so you get that 25 first. And once you get the 25, everything else is easy. I'm going to draw the picture again. Okay, so now we first figured out 100 minus 25, 75 is the count of two circles together. And since the first circle is equal to 50, 75 minus 50 must be this section. And this whole thing is 42. So 42 minus 25 gives you this section, and that's 17. And then 50 minus 17, 33 here. So now we have all the sections. So now we can answer the questions. A question is, how many female students voted Democratic? Female voted Democratic. How many is that? How many female students voted Democratic?
17.
17. This intersection of D and F. That's those are the female students voted Democratic.
How did we get 33 again? I'm sorry.
The 33. Okay. I figured out these 25 as this section, right? Right section of B, the F. Okay. So 42 minus 25 gives you the center part, right? That's 17. Okay. 42 is for the entire circle F. Subtract the 25, that gives you 17 for the middle. Now, 17 on this first circle, D, entire circle has 50 elements. This section, the intersection part has 17. So 50 minus 17, 33 must be here. Okay?
Yes, thank you.
Mm-hmm. All right, so let's do exercise 9. Let me clear the board. Okay, exercise 9 says it's a survey of 75 consumers. 12 indicated they were going to buy a new car. 18 said they were going to buy a refrigerator. 24 said they're going to buy a stove. 6 were going to buy both car and refrigerator. 4 will buy car and stove. 10 will buy stove and refrigerator. Only 1 person will buy all 3. Okay, so there are 3 things involved clearly. So we need 3 circles in the Venn diagram. And I'm going to identify, there are altogether 75 consumers who are interviewed. So 75 for the universal set. And all the people who are going to buy car, call it C, 12 elements are there. All the people who are going to buy refrigerator, call it R. And there are 18. All the people who are going to buy stove, S, has 24. Okay, 6 will buy both car and refrigerator. So does that mean I can put the 6 here or not?
Yes.
No, that's a common error. That's why I wanted to bring that out. That section is not 6. Oops, I erased it. Okay, that's all right. I'll start over. Okay. The C has 12 and R has 18. S has 24. And then it says 6 people will buy car and refrigerator. So that's the area common to car and refrigerator. That's all of this, not just this part. So that's why we cannot write the 6 there. The area common to C and R is this entire section, which includes part of the area common to all 3. So this whole thing is not 6, it's this and this together is 6. So I'm going to leave it out. I'm not writing that anywhere. And then it says 4 will buy car and stove. Again, the same thing. Car and stove will be the entire area common to C and S, and that's cannot be marked yet. 10 will buy stove and refrigerator. And let's go to this last statement. One person will buy all 3 items. So where's that one going to go? That one person, where would that be?
Middle.
Middle, the middle of all 3. All 3 sets intersect right here. This is the common area for all 3 sets. There's one person in that section. Now we can go back to the other numbers. This whole thing is equal to 6. So what's the number for this part?
5.
5. Because this one has to be subtracted from that. Okay, going back to C intersection S, cars and stove. How many people are buying car and stove? 4 are going to buy car and stove. So what number goes here?
3.
3. And refrigerator and stove, 10 people will buy refrigerator and stove. So how many are going to go in this section?
9.
9. Okay, so now we are ready for the sections of the C. Go to the section C. 5 plus 1 plus 3, 9 elements are in these sections. If I subtract the 9 from 12, I'll get the remaining section, which is 3. Okay. Now again, R has an unknown section. So add 9, 1, and 5, that's 15. Take away 15 from 18, I'm getting 3. So there are 3 elements here. Similarly, in the other circle S, 24 minus 3 plus 1 plus 9. 24 minus 13 is 11. Finally, to figure out how many are outside, I have to add up all the numbers in all the circles, all the sections, and take away from total number, which is 75. 75 for the entire set. Okay, so let's add these sections. There are 24 elements in this entire circle, 24. So 24 plus 3, 27 plus 5.
I think it's 35.
35, right. So when I add all the section, I'm getting 35. Subtract the 35 from 75, you get 40. There are 40 elements outside. Okay, so let's now start answering questions. How many were going to buy none of these items? What's the answer?
40.
40, right. Second question, how many are going to buy only car?
3.
3. 3 will buy only car. C is, how many are going to buy car or stove? Car or stove will be union of C and S. So that will be all the numbers in C and S have to add up. Entire S has 24. So 24 plus 5, 29 plus 3, 32. 32 are in the union of C and S. Part D is how many are going to buy car or stove, but not refrigerator. Car or stove, but not refrigerator.
17.
17 is right, very good. Why is that 17? Because car or stove means union of the C set and the S. We found 32 elements there, but this time we are counting the people who are not buying refrigerator. So they must be either buying car or stove, but not refrigerator. Can you see
I
that?
have a question.
Yeah.
So for letter C, it says how many we're going to buy car or stove.
Mhm.
Wouldn't we have added the numbers without the refrigerator? Right?
Yeah, for that question, we add all the numbers in C and all the numbers in S, right? It's just C union S. That's what that is.
So like the full circles, even including the intersection?
Yes, including the intersection.
Okay.
The part in the intersection is also either buying car or stove. They are buying both. So they are counted in the people who are buying either, right? So the intersection will be counted as part of the that answer. But the next part, how many are going to buy stove or refrigerator? car or stove, but not refrigerator. So that would be all the people in C and S together outside of the R. Outside of the R means only this, right? So the 3, and the 11 have to be added up. And so 17. That's the answer to part D. Part E is how many are going to buy stove and refrigerator but not car? Stove and refrigerator but not car. Anybody?
23.
Stove and refrigerator but not car.
It's 9.
9. These 9 people are buying both car, refrigerator, and car and stove, but not car. This one person is buying refrigerator and stove and car. So he has to be eliminated from that. These 9 people are the only ones. Okay, everybody's good with that? All right, now I'm going to do as much as I can on the next problem. We have done everything we need to, but this will be helpful if I do it. So let's do the number 10. The cars sold in certain month, they're comparing the properties of these cars. So let's put that on the Venn diagram. And it says 90 have heated seats. 90 of those cars have heated seats, age 90. And 80 have GPS, GPS 80. And 75 have radio 75. And then it says 20 cars have none of the extras. Where do I put the 20?
Outside.
Outside. 20 of them had none of these features. And then 50 cars had only heated seats. 50 cars had only heated seats means this is what 50. The cars that had only heated seat and none of the others. This section of H. Okay, mark that. 60 cars had only GPS. That we can mark, only GPS. It would be that. And then 9 cars had both GPS and satellite radio. 9 cars have GPS and radio. So that 9 is the intersection of G and R. That would be all of this, right? So we cannot put that number yet. That's both of these together. And then that's all the information given. And the total number of cars they looked at is unknown. Okay, let me read it again. 90 had heated seats, 80, 75.
What about the 5 had all 3?
That's the part I'm missing. 5 cars had all 3. That's what it is missing.
And it'll go in the center, right?
Center, right. So the 5 cars go here. And so the other statement, 9 cars had both GPS and radio. From that, we can tell this section. How many are here?
4.
4, right. So now we are ready to calculate the remaining parts. If you look at GPS section, 60 plus 4 plus 5, that's 69. Take away from 80 to calculate this section. So 69, 70, 80, 11 goes here, right? I added 65 and the 4, took away from 80 to get the 11. Now, once you get that, we can go to H to calculate this unknown section here. So 11 plus 5, 16 plus 50, 66. So take away 66, 24. So 24 are here. And finally, now we can go to R and figure out this section, 24 plus 4, 28 plus 5, 33, take away from 75. 33, take away from 75, that's 2, 4, 42. So now we have all the numbers available. So we can start answering questions. How many cars had both satellite radio and heated seat? Radio and heated seat. How many?
24.
24 is this section. No, that's incorrect. How many cars had heated seat and radio?
29.
29. The 24 plus 5. That's the intersection of H and R, all of that. So part A is,
Interfere with the GPS though?
the question is how many cars had satellite radio and heated seat? Yeah, some of them are going to have GPS, but they didn't say not GPS, right? They can have GPS.
Oh, so we could add GPS since they didn't exclude it.
Yes, you have to
Okay.
stick to the question. The question is how many have satellite radio and heated seat? All of these 29 have satellite radio and heated seat. Only if they say they should not have GPS, then you have to eliminate the 5. Okay, so they can have GPS. All right, so going on to next question. How many had either satellite radio or heated seat? That will be radio and heated seat union of those, right? It says either satellite radio or heated seat. So that's union. Means you have to add up 2 circles together. This circle has 75 elements, plus 50, 125, plus 11, 136. That's the count of the union of H and R.
Couldn't we just added 75 and 90 together?
No, 75 and 90 includes the intersection twice, right? Twice.
Okay.
So if you add 75 and 90, that's going to count the intersecting part twice. That would be wrong. So you have to add up the sections or apply the union rule, something like that. You can apply a union rule if you want. But the count for each section is available, so just adding them is the easiest way. Part C, how many had neither satellite radio, no GPS? Neither radio, no GPS.
70.
70 is right. Because outside the circle for R and G, there are 50 and 20. And part D is how many cars were sold in July. So that's the universal set. To find universal set, I had to add up all the sections. These 2 circles, H and R together were 136. To that 136, if I add the 60, that's 196. 196 plus 20 is 216. 216 is the total count of all of those sections. So that's how many cars were sold. That's how many cars we are looking at in the universal side. How many had only one of the 3 extras? Which number should I add up? How many cars had?
50, 60, and 42.
Right, 50, 60, and 42. Those cars had only one of the 3 things. So that's 102, 152. Part F is how many had neither satellite radio or heated seat, but not GPS? Sorry, how many had either satellite radio or heated seat? So heated seat and heated seat or radio, union of these 2 circles. H and R,
25?
not
Oh,
GPS.
24, sorry.
50, no, it's not. No, it says either satellite radio or heated seat, but not GPS. So it's a union, right?
50 plus 24 plus 42.
Right, 50 plus 24 plus 42. These are the ones that are in the 2 circles, but outside the G. Right, these are in the 2 circles, H and R, but outside the G. So add these up, that'll be the answer for that question. All right, so we'll close here, we're done. This problem is a little bit challenging. So I would give you this as an extra credit problem.